When we rationalize a one-term denominator that has a radical, we look to eliminate that radical through multiplication. Depending upon the radicand of the denominator, we have a couple of different options about how we can attack that radical. The first option is to simply multiply by the first factor you can find that would eliminate the radical out of the denominator, and then worrying about simplifying later on. So what will that look like for this example? Well, the quickest way that we can multiply this expression by a radical to eliminate the radical in the denominator is to use the square root of 12. We use the square root of 12 because the bottom is the square root of 12 times the square root of 12, which just gives us a 12. But the numerator, because it also has its own radical, we can combine those radicands via multiplication and get the square root of 72y. This is equivalent to our original fraction. You could make the argument that it's not much simpler. The numbers are all significantly larger, but it is equivalent. Despite the fact that it is equivalent, it is not the simplest form of that particular expression. To get the simplest form of that particular expression, we recognize that 72 has a perfect square factor of 36. 36 times 2 is 72. So we can use the square root of 36 to further simplify that numerator, giving us 6 times the square root of 2y over 12. This fraction is equivalent to the previous fraction, which is equivalent to the original fraction, but still not the most simplified form. We finish our work by simplifying the 6 and the 12 down to a 2, and we end with the square root of 2y over 2, the simplest form of the 4 we've had. Despite the fact that you can make the argument that this might not be simpler than the original question, and this might not be simpler than the original question, this is clearly simpler than the original question. And that's really our goal, is to get down to the point where it's the easiest to work with and the easiest with which to complete an operation. Now, you might have noticed at the very beginning that this square root of 12 also had its own perfect square factor of the square root of 4. What if we noticed that at the beginning and then tried to use that? So let's try the exact same example again, just with a slightly different approach. Before we begin multiplying, we're going to rewrite the denominator as 2 to the square root of 3. That's using that perfect factor of a 4 and simplifying that to 2, allowing us to rewrite the denominator. We're not done. We still have a square root of 3 in the denominator. But instead of multiplying the numerator in the denominator by the square root of 12, we're instead going to multiply by the square root of 3. That gives us a numerator of the square root of 18y. And root 3 times root 3 is just 3. Times that 2 gives us a 6. Again, equivalent to our other versions, but still not the simplest version. You should notice that there's a perfect square that goes into 18. That perfect square is 9, leaving behind a 2, which allows us to rewrite the numerator as 3 root 2y over 6. Simplify the 3 and the 6, leaving us with the same answer we got using the other strategy, root 2y over 2. Either one of these strategies is appropriate to use when simplifying. Both of them reach that final destination of root 2y over 2. It's nice to have both of them in the toolbox, thinking through the simplification at the beginning versus having to do all of it at the end. This has a tendency to keep the numbers, this strategy has a tendency to keep the numbers a little bit lower, maybe a little bit easier to do by hand. This one has a tendency to make all of the simplifications in one step. So we saw that when we went from there to there. So it's really, as beauty is in the eye of the beholder. You can choose either one of those strategies for any situation. If there is no perfect square in the denominator, then this is your route. You're just jumping right into eliminating that radical. So let's take a look at one of those. Here we have 14xy over root 3x. We're not alarmed by the variables, similar to what we saw in the previous example with the y. we're going to multiply the numerator and denominator by root 3x. Just remember that we do this because that fraction is equivalent to 1. We're rewriting the fraction. It's the same logic that we use when we simplify fractions and we divide the numerator and denominator by the same thing. So multiplying by root 3x, we get 14xy root 3x. We don't want to combine any of those. The 14xy is not part of any radical. Root 3x times root 3x just gives us 3x. Only one more simplification visible here. This x simplifies with that x. We're assuming everything's positive, so we're not super concerned with any kind of absolute values or things not dividing. Obviously, we would say that in this case, x isn't allowed to be 0 because it wouldn't exist. So all of those things that we sort of assume that allow this to happen are all true. And we're left with 14y root 3x over 3. Resist the temptation to cross those threes. One of them is not a radical and one of them is not. And you don't have to do anything extra with this 14 over 3. I see some people who like to rewrite expressions like this. I don't advise that. There's something to seeing the numerator as the numerator and the denominator as the denominator and not just trying to work this as a coefficient of that radical expression. So the logic was the same for all of the one-term denominators. Multiply in order to rationalize the denominator. We don't want any radicals in the denominator. And then do any kind of simplifying that you need to after that. Some of the simplifying will consist of just basic algebra 1. I see an x, I'm going to cross it out simplifying. And some of the simplifying will consist of using our skills for simplifying radicals, where we were looking for those perfect squares, perfect cubes, depending upon the power, and making the decisions based on those.